Let's talk about the, what was the brand name? Branding? It's Dayton Audio. You know, probably in cahoots with Parts Express. It's a digital signal processor. It's based on a chip that's the ADAU1701. It's a module that's the top part of this stack. The under part of this is a daughter board or an accessory board that comes with it. And this board over here is a board that you use to program it. Digital signal processing means you take a signal from the analog world, run it through an A to D converter, and as that digital data is flowing through the processor, it digitally modifies it. You can do a lot of things, a lot of really cool things. It's very powerful. Simple filters, you know, first order, second order, very common. You know, you can have in order filters, so your slope is like that. Crossovers, fancy things like fat bass. You can do fine tuning with parametric equalization, which is kind of popular right now. There's a lot of people talking about how they like to be able to not just have a multi-band equalizer, but being able to control where the bands are and the frequency range and the shape of what the EQ is doing. You know, be it notch, the shape of the curve of the notch. That's all what we call parametric. It has that. It has a third output, which is for, well, you can route anything to it, but the powerful bit is that you can route bass. So you can use this as a way to get bass management. I've got a big project going on right now. I'm building an amplifier. I've ordered modules from China to make the amplifier section out of, and I'm going to use this as the sort of a preamp. It's going to handle a lot of tasks for me, like volume and treble, bass, yada yada. It can do all of that on its own. I guess at this point, let's kind of go through what we have on the table here. This is just powering it. It's USB. From my phone here, I'm running through this little cord to the input into the daughter board. Now, all the connections from the daughter board up to the DSP module are made through this set of wires right here on the side. This sort of a cable. The output right now is over here coming out on these two RCAs, and I've also got this one plugged in the middle. This is going to headphones. The RCAs are coming over here, and this kind of dead ending right now because I don't have my amplifier in place. All this is, there's a little bit of limiting resistors over here, but the amplifier input would be connected in here. Back over here on this side, this strip of wires is going to general purpose input output pins for the digital processor. And over here on this side, this is ground going to the breadboard. The red wire is plus 3.3 going to the breadboard. The reason I've got them coming over here right now, it is to create a power bus for these pull-up or pull up or pull down, whichever one, resistors they are for these switches. So these toggle switches are, I think, pulled up until they're pushed, and then they go to ground, or vice versa. I'm not really sure which, I don't remember. Comes up here and it connects to the general purpose I/O input pins of the DSP. Let's forget about this one for a minute and this. I'm going to talk about that later. So the DSP has the ability through software to connect through what we call general purpose interface pins, general purpose I/O pins, and have a way to, I'm going to try to open that file, GPIO toggle. It basically can have its own hardware control over, you can build your own hardware control over the digital signal processing via A to D converters and general purpose I/O pins. The A to D converters are tied to potentiometers. It has 4 A to D ends that are not part of the audio track. If you look here, I didn't mention a minute ago, on this side of the board, there are 4 potentiometers, top level, that are 4 small potentiometers. So those come mounted on the board. Of course, you can set those all to their max resistance and then wire out your own potentiometer. So that's like, and there's a number of GPIO pins. I'm not really sure how many, maybe like 8, maybe, I don't know, around that range. I mean, I've got all of these running down there. I've got 5 running down there. I'm only using 3 of them. So there's at least 5. So that's 5 GPIOs, 4 A to Ds that you can use to control the digital signal processor. And the software has, let's call them components. I don't know. You have these little components that you drag onto the schematic, right? And you can use them to create pretty much anything in the digital processing world you sort of want to. Just kind of real quick going over this little schematic. You've got this input block. It is controlled by an A to D converter. This A to D converter 0 is hardwired to one of the potentiometers on top of the board, and that's going into this master gain control here. All right, and it's all 2 channels, so you've got 2 channels coming in, 2 channels coming out. That's the very that's like the beginning of almost all of these little schematics you want to do. And here is an example of where you've got a GPIO pin coming into this toggle detector, and what this thing does is it looks at the state of it notices the state of the pin changed, right? It reads from a register to see what it was, and it flips it to the opposite of that, saves that in the register, and then sends that signal down here to this thing. This is a demux, or basically it's just an analog switch. So depending on whether this is high or low, this mux is going to route the signals coming into it off somewhere else, right? Either up or down, either to the upper side up here or down to the lower side. And then over here we have multi-step tone controls that you can set up in here. And the way this one up here works is that depending on the position of the potentiometer, one of those bands in that array of frequencies gets selected. So that's how in this case the bass is implemented. You can kind of see how incredibly powerful this can really be, and it's set up so that it can have its own hard wiring, right? You can have potentiometers and switches and push switches connected to it to control things, right? Your volume, your bass. Maybe you have a loudness button, things like that. Now, the way it comes when you order it, it's got a default program coded into it that is kind of set up for a subwoofer, where basically it gives you, it had a way to give you a high pass and a low pass, you know, and to separate off the bass. And everything was controlled with the little potentiometers on the board, and that's it. The 4 potentiometers did do things. Wish I could remember what they were. So if you want to do anything with this, so let's be honest, ordering it just to use it for that without modifying the program that's on it is a pretty limited sort of thing to do. And the daughter board down here makes it so that you can connect up to it with common connectivity, RCAs and, you know, 3.5 millimeter. In order to modify the program, you have to have this little programmer card down here. I was a little upset about it because it's kind of expensive. I think their reasoning is, well, I mean, there's a lot of components on here too. It's complicated and it's expensive. And I guess the reasoning for them is that, well, you're going to use it over and over on many different boards. You know, you're going to get a you're going to get a 1701 and do something with it, and then, I don't know, sell it or use it or put it in your boom box or your Bluetooth box that you built, and it's going to be gone, and then you're going to get another one and you're going to use this again. I guess I see the logic in that, sort of. I could also see a scenario where you might want to let this go with your product, if it is a product, if you're going to like build something and sell it to somebody. And it has mount holes there, right? Like you would want to, you might mount it and let it go with the product, but you can't leave this cable connected to the DSP and then plug the USB into it and use it. It won't work that way. You have to have you have to disconnect it from the DSP, plug your USB into it, get the software to recognize the USB, and be happy, and then plug it into the DSP. Which means, right, you can't install it in something and have this already connected. It's dumb. So anyway. What is the value proposition to this thing? So obviously, if you're going to create more than one, like for me, say a preamp or an amp or something like that, then yeah, you know, you're going to program it. And this thing is nice in that the program is interactive. Like I can have this thing interactively connected. I can come in here, for example, and then I can maybe say, I can change the center frequency of the curves on this second order filter array of second order filters. So, right, I can change the center frequency, hit enter, and it happens. It's immediate. Right, I don't have to compile that, save it off into a binary file, and then transfer it down, and then, you know, boot it and see what it's going to do. Now I could live with that second world. I could live in that second world and not buy this. This being interactive to me is not worth its expense. So, and I think that maybe what I've just described, where you can compile it and download it, I think there may be a way to do that without having to have this little card over here. But let's say I wish I knew, what is the total price for all this? Let me see if I can find it in my Amazon. Is that right? I didn't pay $70 for these things, did I? Oh, I feel like I've... So the DSP itself is 20 bucks. You know, that's reasonable, I think. The daughter board that makes it so that you can connect it to common things is another $10, which, if you're going to use it, depending on how you're going to use it, that's okay too. But if you were going to build something and put this inside of it, you would probably just want to you don't have to have these connectors down here. You could just solder, or you could just connect the wires directly through these plugs. So I don't know if that's really worth it either. And then the programmer that allows you to program it over USB is another $25. So what is that? That's 65 bucks. Okay, so for 65 bucks, and let me say right now, it looks like this thing has line level power, right? It's got RCAs, and it's got, you know, 3.5 millimeter, which maybe you think, but it's a lot more powerful than that. And I'm not sure if it's the daughter board that's adding that ability, but it will crank a pair of headphones. It's way too powerful to probably feed the raw input of an amplifier. In fact, I think I may have damaged my amplifiers because this thing was way too hot on the input. So the reason I say that is that this thing is for $65 is a really powerful headphone amplifier. It could be marketed that way for someone that has the technical savvy to program it, to get into this, you know, SigmaStudio. Analog Devices that's the company that makes the ADAU1701. To get in here and play with this, tweak your headphone amplifier the way you want it, right? Make these controls, these volume control, or these potentiometers out here do what you want them to do. They're made to set and forget because, you know, you have to kind of use a screwdriver to turn them. That's kind of a bummer. It would also be, you know, if those were actually knobs you could turn with your fingers, and if there maybe like was there 3 or 4 buttons on this thing, well, that would be, I mean, just by itself, it would be a very powerful little headphone amplifier. Probably worth the, you know, the $65. Now, it's probably a little too complicated for the everyday headphone amplifier consumer. But for the power headphone amplifier consumer, it would be a pretty powerful, and it's a pretty good price proposition. So let's move on to what's going on over here. These 2 wires coming down to the breadboard, coming back up to this little module here, which is an ESP32 with a display built onto it. So I mentioned all about how the DSP has the ability to have its own knobs and its own buttons, right? But you don't get any kind of a remote control that way. So, and this little module here, it's a little pricey at 20 bucks. A lot of that price is the display, which is a little bit extortionate, but for what it is, you can get an ESP32 for probably 10 bucks, but you do kind of need a display. And in my amplifier build, what I'm doing is I'm using the ESP32 to control the DSP, so that I can, and the ESP32 will monitor all the rotary encoders and buttons, and it will also have a display that way, right, where you can show on the display the number. Like if you might want to change your bass from 0 to plus or minus 1, it shows that number, it shows the word bass, and it shows the number on the screen here. Let me show you an example. I think it's running right now. And I'm not done with any of this yet, right? It's still a work in progress, but I've got a little program already downloaded and running on there where I can send it commands. And it will, well, that's telling me that basically the bypass is on. So let me turn that off, or actually turn it on, color. Color means color my sound in a very non-audiophile way. So that's color toggle. So the color's back on now, and now I can maybe change the bass. So I can say bass up, and now it's gone to 5. I can lower it back down. Right, so the bass is now at 4. This will show on the front of my amp. I'm typing it in over here on the keyboard and it's sending it down the serial, right? So, but imagine this thing, this ESP32 has Wi-Fi capabilities. So I'll be able to control the amplifier over the Wi-Fi. And it's also monitoring the front panel controls, right? That's what that's for. Now, the way it communicates with the ADAU1701 is through an interface called I2C. That's what these 2 wires are. It's not exactly 100% straightforward how to do it, but I've figured it out. So I guess if you're interested in interfacing an ESP32 or probably anything on on the I2C bus to an ADAU1701, give me a shout out. So at $65, is all of this a good deal? For the right person, yeah. That audience is probably pretty limited. For the everyday, the normal headphone amplifier buyer, even though this thing is not advertised as a headphone amplifier, I'm here to tell you though, it's a pretty good headphone amplifier. It's very powerful, and if you're, if you have any skills on the computer, I think it's fun. It's a fun thing to play with, right? And it sounds really good. You can tune that. You can tune your music. You can tune your. You could tune your headphones. You could tune anything that you're feeding with this thing to the nth degree in the digital domain, right? Now, that domain is it's 12-bit, I think, 12-bit 48 KB, right? It's not going. So your high-res music is going to get lost on this. If you think you can hear the high-res 96 KB or above sound, you're probably not going to be interested in this particular digital signal processor, but it's got plenty of bandwidth, and it's doing A to D. It will accept an I2S input. It also has I2S output, but I haven't tried to use that yet. I will try to use that. I'm planning to. Which means that you don't have to use its built-in A to D conversion. ADAU1701 from Parts Express and Dayton Audio. There's a Chinese version of this out there that might be a little cheaper. Okay, that covers it.